The following is a presentation of the Six Arrows Radio Network.
Today on the Workbench, all about power supplies and listener questions. Stay tuned. Welcome to the Workbench. I'm your host, George, KJ6VU.
And I'm Jeremy, KF7IJZ.
This episode is sponsored by CADsoft, makers of Eagle PCB design software. Get your free copy of Eagle at www.cadsoft.io. And by MCM Electronics. For all your electronic parts and equipment, go to www.mcmelectronics.com. Hey, welcome back to the Ham Radio 360 Workbench podcast.
Episode 3. You guys are still listening. We're still making them. So thank you so much for being with us along this journey. It's been enjoyable. We've had a lot of great feedback since the last episode. And George, how you doing?
I'm doing great, Jeremy. Thanks.
Stop the presses. It just broke today. Hera Arena is no more.
And no more meaning it's not going to be Dayton Hamvention next year?
Okay, you're right. I overstated it. The building's still there. But in an article I read from a news source in Dayton, August 27th, I believe, will be the last time an event will be held at the Hera Arena as we know and love it today. So what this really means is no Dayton Hamvention at Hera Arena.
Do they have a new site picked out?
Not that I have seen. Oddly enough, the folks at Hamvention, which we've been following them on Twitter at Hamvention, have stated that the date will not change, but they have been very tight-lipped about a new location. And I'm really curious if they knew this was coming or if they found out the same time that we did.
Well, I know they've been looking for an alternative location for a few years just in case, but I don't know if this was late-breaking news to them or what.
Well, gone are the days of the falling ceiling tiles, the black mold, and the broken up wooden floors. Which I was going to say, look, I make that sound a little bit. I make that sound actually very negative, but I don't know. It's part of the character. I've only been going to Dayton for about 4 years now, but it's never really bothered me.
No, you're there with all your ham radio friends looking at all the different vendors and the flea market and everything, and you sort of don't really care what the place is like. It really was a little rickety, but it's got a long, long history. It's really a shame in a way that they would close it down, but I hope they could find a venue that's in the area. Yeah,
because then, I mean, it needs to still be the Dayton Hamvention, and to do that, it needs to be in the Dayton or the greater Dayton metro area. As we know more, follow us on Twitter and whatnot, and of course, when we do know more, we'll talk about it more here or on Ham Radio 360. So that's a big piece of news, but we actually have another huge piece of news for the show.
Tell us about it.
I am happy to report that we have brought on MCM Electronics as a new sponsor. If you guys listened to the last episode, you saw that we had a promo code from them that they had graciously shared with us as we were working out the details. But everything has been finalized, and we are very excited to bring MCM Electronics on as a new partner. MCM Electronics is a company that I have been shopping with for years and had only kind of recently realized they were kind of in my backyard as far as being in Ohio. But really the value to you guys are a couple things. Number one, they're a trusted vendor who have excellent customer service, and they have a huge catalog of all of the things we're talking about, from power supplies to multimeters, an extensive components and semiconductors catalog, a lot of different hand tools. If you looked at our show notes last time, we pointed to a lot of stuff. I found out that they carry Hakko soldering equipment, which makes me very happy, as well as a wide assortment of Arduino, Raspberry Pi, and other popular maker items. So we are very excited to have them on board. And the good news is it's August. Remember, we had a coupon code or a promo code last time that expired at the end of July. Well, because of our new partnership, MCM Electronics has been kind enough to extend that code. Again, that code is Radio5 to save 5% off your total order on most things. There are a few things they can't discount, like Raspberry Pis and some other stuff. But yeah, thank you guys very much for coming on board.
Yeah, thank you. It's awesome to have you with us.
Oh, you know what? I'm sorry. I didn't mention MCM Electronics website, which is mcmelectronics.com. You can also follow them on Twitter at MCM Electronics. All right, what else do we got?
A couple quick shout outs to some of the listeners. I got some great email feedback from Tim, KE4KE. You can go to ke4ke.com, and he's got a great blog website, a lot of field HF operating tips and gear and ideas and whatnot. So I found that quite enjoyable. So check out Tim's website and blog. And also Vance, N3VEM, has a really exciting activity going on. He's doing what he's calling the Napotathon, which is the NAPOTA. So it's the National Parks on the Air Marathon. And get this. So Vance is going to hit 12 parks and activate those 12 parks in a 24-hour period.
Wow.
Can you believe that? I don't know how you can drive to 24 or to 12 parks in 24 hours, but he's going to go to 12 parks, set up and operate and make contacts in that 24 hours.
That's really impressive. Given the 3, I wonder if he is in somewhere in the national capital region.
I think he is, which, okay, so that makes it slightly easier.
Makes it a little easier, but that's still really impressive. So another thing, well, this involves you too, is I have heard a rumor that Pactenas are back in production.
They are. We got a big pile of Pactena Mini random wire antennas, the ones that work with an internal tuner like the Elecraft radios or any radio with a tuner. So we have a big pile of those now. So they're heading out the door. And we're starting to get our parts in-house to make a batch of Pactena Classics, which is the big fiberglass pole and the link dipole configuration. So we had a lot of people ask about those things, and we were like sold out of those things for 6 months. So we decided to make another batch. Oh, and there's also a really cool YouTube video that I'll put in the show notes. So one of the guys up in Canada is doing a video series about portable antennas, and the first thing he did was the Pactena Mini end-fed half-wave 20-meter antenna. And he shows how he sets it up, and he puts it on the antenna analyzer, and the thing is flat as a pancake at 14.2 megahertz.
Wow. All right, more information available at www.pactena.com. All right, what do you have on the bench this week, George?
With the first thing, I have nothing on my bench because I shipped it to Cale. He has it on his. So I finished off the repeater, got that shipped to him. So that's the UHF repeater that he's setting up in his area. So there's a pair of Motorola CDM radios, one for receive and one for transmit, and they're plugged into a Sierra radio controller. That's plugged in also to a little duplexer, and he got all of that stuff, and it's all wired up, and I think it's working. And he still has to get the antenna and get the thing all mounted. He ordered a 12U wall mount rack to put it all in, which will be quite nice. So I'm sure we'll get a report on how all that's going.
And I talked to him earlier today, and as I understand it, he got his desired frequency pair, so he's well on his way. What else you got?
You know, I've got a little project that we should talk about that's kind of a skunkworks project that I think our listeners will be real interested in.
Shouldn't it be a pigworks project?
Actually, perhaps.
No, I think it's time to spill the beans on what's been going on behind the scenes here at the Workbench.
Okay, so a little bit of background. When we started talking about the Workbench podcast, one of the big ideas in mind was to come up with some designs that we could make available to the listeners and have you build it along with us. So we would design something, figure out all the parts, and communicate that stuff to you guys so you can build a project, and we could do it as a community. So we would all be building the same thing, and we would also be able to walk through the schematic and explain what everything does, talk about how to assemble it, talk about how to test it, and we can all learn along the way. So that was kind of the big idea. So we thought, well, okay, what would that thing be? And a lot of ideas came to mind. And we finally settled on a project which I think is going to be awesome project.
Oh, I agree. It absolutely will be an awesome project.
Should we just move on?
I mean, we've had our listeners be patient with us and have us spend half an hour talking about screwdrivers. I think we should go ahead and mention what it is.
All right. So what we're going to have everybody build is an antenna analyzer.
So specifically, Ben and John, who have been in touch with me for the last 2 weeks, and I've told you something is coming. Don't go out and buy something yet. This is for you.
So this is a thing that a lot of hams would like to have. And an antenna analyzer is a device that you plug into the feed line that goes up to your antenna, and it will generate a signal and sweep through the band, and it'll tell you where your antenna is resonant. So it's super handy. So if you're going to cut a dipole or make a vertical or just tune your Yagi or whatever you've got, you want to know what frequency it's on, and an antenna analyzer will tell you that. And if you want to go out and buy one, there's several on the market, and they're generally in the $200 to $300+ range for a decent antenna analyzer. So the idea here was, could we build one that was much less expensive, that was still perfectly usable? And that way you would get the experience to build something, but also that thing would be super useful and actually save you a bunch of money.
And you would have a good understanding of how it works because you will have built it. And you make a really good point. It tells you where your antenna is resonant, not just its SWR.
Yeah, exactly. So just a little bit of background on this particular antenna analyzer. This started as a project that a friend of ours did. So Barrick K6BEZ, who is part of our ham club here in the Bay Area, he's an RF design engineer. He's been an RF test equipment designer for the last 16, 17 years. And he came up with this idea of building a low-cost antenna analyzer using an Arduino as the controller, and then building the signal generator out of a digital synthesis chip and adding the appropriate additional components to make a bridge so that you can then connect it to your antenna. And he wrote the firmware, did the hardware circuit design, and got it up and running, and the thing works really well. He also wrote a Visual Basic program that would allow you to connect it to a PC. So the way it works is you connect your antenna, and there's an LCD display. You have some buttons. You set the frequency you want. It sweeps it, and then it shows you the frequency that the antenna is best matched at. Or you can plug a USB into the antenna analyzer and into your PC, and you can see a graph on the screen. So that was the original version of the project. He's gone back in, done a few tweaks to the circuit. He's looking at perhaps rewriting the software maybe in Python, so it's very portable. And we took that idea and spent some time with Barrick and talked about how we might want to do this. And we took his design, and I relayed out the board using Eagle. So the board is pretty close to done. So Rev 1 prototype boards are done, and we've been testing them, and we're going to go to a Rev 2 for the final version. So that's in the works, and we're hoping to have it done in the next month or two.
And there's a lot more moving pieces with this, and of course, now that we've kind of let the big surprise out of the bag, if you guys hang on with us, we'll start piecemealing information as things come together, and we'll make sure to include a link to that in the show notes so you can get familiar with his what the starting design was. I do have a question. You said Python. Is there a Python to Arduino compiler?
Well, you can talk through Serial.
Oh, so it's the computer control software. Okay.
Yeah, so the Arduino is going to have the essentially the USB to COM port interface on it. So when you plug an Arduino into the PC, it enumerates as a COM port, and then with Python, there's a package called PySerial, and PySerial allows you to talk from the Python code to the UART.
Yes, I completely misunderstood what you were saying or wasn't paying attention, but I'm picking up what you're putting down.
Yay! There you go. So, well,
go ahead.
I was just going to ask, I want to hear about what's on your bench, because you're working on something that is really interesting to me, and I'd love to hear more about it. And that's all this work on the batteries.
Yeah. So if you follow me on Twitter, you have seen a string of battery discharge performance reports, and the frequency between which continues to get longer and longer, because I started with the high current tests and went to moved down to the low current test. So Kevin from BioNO had sent me one of their lithium iron phosphate battery modules. It's an 8 amp hour, 12 volt equivalent battery module that has the majority of your protections in it. So over current protection, over voltage protection, under voltage protection, as well as the battery management system required to make sure that all the cells are balanced internally. It is a 4 series 3 parallel design, which is why it is rated at 8 amp hours. And he had sent that to me, and I was going to stick it on my Menuo DC load. And as I started running it through the first set of tests, I was like, you know what, that's not good enough. I happen to have a brand new 9 amp hour rated AGM battery that I had just purchased to replace some batteries that failed in a UPS. So literally brand new, had never been charged or discharged. And then, of course, I still have my A123 Systems ALM 12V7 that Gerald and I are huge fans of. And so I've decided to start running them through the gamut of tests. And of course, I've been posting the results on Twitter, but we'll be doing a video actually comparing the discharge graphs for these. Right now, I am it's the end of the first series of tests, which the first series of tests were constant current discharge. I discharged them at 10 amps constant current, which is what the rating of the battery is. Then I discharge them at 2, which simulates something like an FT991 on receive. Discharge it at 1 amp, which simulates something like a 7300 or like an 857 on receive. And then I'm currently finalizing the last test on the running at a 1/4 amp, which would simulate running a KX3 on receive only. And then I'm going to put all these together in graphs and then compare lifetime performance. For instance, the lithium iron phosphate battery should be good for about 2,000 discharge and charging cycles, whereas the AGM is going to be 500 to 800, probably closer to 500 because this wasn't a terribly expensive battery. And then I'm going to start comparing costs. Now, I've been talking a lot, but the real breakthrough thing on the BioNO battery that has me so excited is that the battery alone for the 8 amp hour equivalent is $95.
Now, when you say 8 amp hour equivalent, you mean like a sealed lead acid 8 amp hour battery, which is really like 4 amp hours, or do you mean like a 16 amp hour, which would be really 8?
No, it's really, it's actually 8 amp hours. That's the thing about lithium chemistry batteries is that they don't, the Pukert or Pukert, I don't know how to pronounce it, but the Pukert coefficient for lithium is such that you can increase the discharge rate and the overall amp hours do not decrease all that much. So for instance, at 10 amps, I think I got 7.3 amp hours, and at 1 amp, I got like 7.6. Whereas with the AGM battery, at 10 amps, I got like 0.75. I'm making that up, but it was like around 1 maybe. I don't have the data in front of me. In order to get the 9 amp hours, I had to run it at a 1/4 amp, to get something close to what it's rated at. That it is actually an 8 amp hour battery equivalent. And I say the equivalent because they're slightly less than 8, but I think the worst test I ran was like 7.3, which is still less than 10% deviation from the rated, which is incredible. I can't it will actually has been running for a day and a half downstairs. It's still not done on the 1/4 amp test. If you want the charger with it, it's $107. I mean, I am super pumped about these batteries.
So with all that work on the batteries, when are you going to publish the final analysis of the different batteries?
It's going to be a few more weeks because I'm finishing the constant current run right now. Next is going to become simulating an operating load with a duty cycle. So I plan on simulating, what happens with a 100-watt radio run at about 50 watts, and say a duty cycle of 50% transmit, 50% receive, and then simulating the same thing with a KX3, which is like a 1/4 amp receive, and then 2.5 to 3 amps on transmit.
So one of the things that's really confusing, if you look at a bunch of data from this kind of analysis, it's sometimes hard to know what to make of it. So when you're done, would you be making some recommendations?
Oh, I'll bottom line it right now. The BioNO is a clear winner for the price.
Do you need a balanced charger, or can you use a simple charger for that?
You need a charger that does constant current, and then we'll switch over to the proper constant voltage. But the actual balancing happens with the battery management system inside the battery. The base battery is like $94, $95, and then 107 with a 2-amp charger.
Oh, so that's really reasonable.
Yeah, no, it's insane. Go buy one right now. In fact, actually, I'm surprised you haven't ordered one while we were sitting here.
You know, I've got the A123, and I've got a bunch of batteries. All right. Anything else on the bench before we move on? My
little Titera MD380 DMR radio, which I still love. I've actually even started using it for analog repeaters here recently. But the charger has developed a fault in the power port on the back of it, the thing that you would actually plug into the wall wart to charge the batteries. So I gotta take that apart and figure out what's going on, because unfortunately I have not seen where you can actually order just a new charging cradle. It's a 12-volt charger, so maybe it's time to rip off that plug and put some power poles on it.
There you go. Just splice in a power pole.
Power pole the world.
All right, cool. So I think that's it for our news and updates. So
shall we move into power supplies?
Yeah, let's do that right after this. The Workbench is sponsored by CADsoft, makers of Eagle PCB design software. With hundreds of parts libraries, tons of reference designs, and a huge user community, Eagle is a great choice for your next ham radio project. Get your free copy of Eagle at www.cadsoft.io and start designing today. So, Jeremy, let's talk power supplies. When we talk about power supplies, what are we going to be talking about?
So for your Workbench, there are generally two categories of supplies we're going to cover. Number one is one that is a ham you are most likely already familiar with, and that is your standard ham, quote unquote, 12 volt or 13.8 volt power supply. And this is more of a high current power supply designed for powering radios and other such high current ham devices. And we're also going to talk about bench or lab style power supplies, which are a little bit more of a precision instrument and generally tend to be much lower power, lower current devices, and have some special features used for working on electronics on your bench.
So when we talk about the 12-volt supplies, I guess there's really two applications for that. One, like you said, is really running the shack. The other application is having a high current power supply to test out stuff on the bench, but it's really the same kind of power supply, right?
It is. And if you set your bench up like I have, for me, it's not just a 12-volt power supply. I have a West Mountain Radio rig runner, so I have several power pole ports. And then basically provided myself a 12-volt rail on my bench where if I need to have an application where I'm just trying to run a 12-volt device that I'm using and current limiting isn't a problem and it just needs to plug in and work, that's another application for this style of power supply.
Okay, so when we talk about these sort of power supplies, of course, not all power supplies are equal. So what would you look for in a power supply?
Well, the first thing I think that comes up, and to be honest with you, I don't even have a good explanation of this, except for you generally run into two kinds. You run into linear power supplies and switching power supplies. And the first thing most hams will say about those two things are a linear supply is really RF quiet and very heavy, and a switching power supply can be RF noisy, but not all of them are. So, George, what is really the difference between a linear and a switching power supply?
Well, it really all has to do with how the power supply converts the 120 volt AC to 12 volts DC and how it regulates it. So there's a couple of approaches to it. So a linear power supply is one where it's a very traditional kind of power supply circuit. You have a transformer. The transformer converts the 120 volts down to something lower like 18 or 20 volts. That gets rectified. You have filter capacitors, and then that DC voltage goes into some kind of pass element, a big transistor or a bank of transistors, and those transistors are controlled by a voltage regulator circuit that ensures that the DC output voltage is always the voltage that you set. So whether that's 12 volts or 13 volts or 13.8 volts, that output is going to be always at that voltage. So it's the appropriate voltage for the target. So that's a linear supply. And a switching power supply is a little bit different. A switching power supply has a circuit in it for regulation, which allows you to use much smaller transformers and is also much lower heat dissipation and is in many ways more efficient. The switching supplies essentially have an oscillator in the circuit, and it converts and regulates the voltage and allows you to really get along with a much smaller supply. In the early days, the first switching power supplies were a problem because with an oscillation circuit inside the power supply, it's creating some signal, some noise on some frequency somewhere. And if you're unfortunately unlucky, that's going to land on a band or a frequency you're listening to. So that was a bit of a problem. So power supplies that were not intended for ham use could be very noisy and still could be noisy. But the ones that are really designed for ham use typically are much better. So the net effect to the ham really is one of size and weight. The pricing is about the same. So a power supply at a given current that's an analog linear supply is about the same as a switching supply for the most part, but the switchers will be much smaller.
And lighter.
And some of them have features which are kind of ham-friendly, like the ability to move that oscillator's frequency off of its normal frequency in order to avoid the ham bands, for example. And better ones, you don't even need to do that.
I was going to say, we'll get into recommendations here in a second, but another feature that you will find in these high current, quote unquote, ham supplies is some of them have the ability to adjust the voltage, and some of them are set at a fixed voltage, or may have an internal adjustment to set a single voltage for the supply. So, George, which do you think is better to have?
Well, of course, like everything, it depends. So 90% of the time, what everybody really needs is a fixed voltage supply, a 13.8 volt power supply that has no way to change the voltage, because you really don't need a different voltage for the most part. The only time you really need to have a variable voltage when you're powering radio equipment is if you are driving that power supply into a battery charging system, not just the load itself. So in the case of my shack, for instance, I have a large deep cycle battery, and I run all of the radio equipment off that deep cycle battery. And I have a power supply which is used to constantly trickle charge that battery. And the thing that's in the middle of all this is called a power gate by West Mountain. Now, to make that all work properly, what I need coming out of the power supply is not 13.8 volts. I need something like 14 or 14.1 volts. I forget exactly what. So I have to goose the power up a little bit out of my supply. So I got a variable voltage supply. But if you're going to run your radio straight off the power supply, you really don't need that. You just need a fixed 13.8.
Now, and some fixed supplies, though, also have an internal adjustment you can make to set the one voltage point. Is that correct?
Yeah, most supplies do. Most supplies, if you rip them open, you'll find a pot in there somewhere, a small trimmer potentiometer, and you could twiddle that pot and move the voltage up and down a bit. You generally never have to touch it. So it's really not something that's normally accessible to the customer of buying the power supply, but often there is a pot inside to adjust it. The linear supplies that have been made forever, like Astron supplies, which are a very good brand of linear supply, and they make switchers too. Astron's linear supplies are like a classic circuit reference out of how to build a power supply. They use an LM723 voltage regulator, which has been around for decades, and that controls a set of high current pass transistors, typically 2N3055s. And if you want to build your own power supply, that's the heart of what you need. A big transformer, big filter caps, that regulator circuit, and some big transistors, and you've got a linear power supply. So you can build them yourself, or you can just go buy one.
So another feature that you will often, and another option, I guess, in these supplies is meters to measure the voltage and current or the load on the supply. Yeah,
and that's really a question of whether or not you want to spend the money. So if you're using a fixed voltage supply, it should always be putting out the right voltage. And the amount of current it's drawing is sort of interesting, but on a daily basis, you don't really need to know either of those things. So if you're looking to save a few bucks, I would not get one with a meter. But if you don't mind spending another $50 or whatever the meter version is, then sure, why not? So that's necessary when you have a variable voltage supply like a bench supply that we'll get to in a moment. That's essential. But for a big 12-volt DC supply for radios, it's really a luxury.
Well, I'm personally a big fan of having meters because first of all, I like to measure everything. I like to know everything going on with my power. So most of my bench tops have meters. Now I have a couple of utility power supplies that do not, but generally I will plug a meter in line when I'm using them. In addition to that, as far as these power supplies, generally speaking, 99% of them will have some type of a binding post for putting a ring terminal around to get a really good connection. Any other common connection points on most of these?
No, most of the supplies are exactly that. They're a 5-way binding post where you can put lugs on it. You could plug in a banana connector. Some of the power supplies have Anderson power poles, which is really, really handy to have because a lot of the radios and certainly most of the power distribution systems in ham shacks use power pole connectors. So like some of the PowerWorks power supplies have power poles built into them. The other thing you might see are just studs and nuts. So the high current Astron supplies, like a rack mount Astron, an RM50 or something like that, that just has a bolt and a nut and some lock washers. And so you would put the ring lugs on your wire and then just tighten it down on the bolts.
And when we talk about hookup to these, generally speaking, in all DC 12-volt applications, it's important to use the largest gauge wire that you can. And honestly, I don't like to go below 12 gauge wire for anything connected to a power supply. You want to keep your runs as short as possible and use 10 gauge if possible. And honestly, you have your options because you can either make your own cables if you are set up with the appropriate crimpers and things that we talked about in the last episode. But then PowerWorks also sells a line of different hookup cables, which I believe are 12 gauge cables that are, say, terminated as rings on one side and power poles on the other. And they even on their website have a build your own cable utility. You select the length and what connectors you want on either side. But again, it's important to have as large a gauge cable as you can to minimize voltage drop across the run on high currents.
So last episode we talked about using a power pole crimping tool. I think this is a good point to bring that idea back in. If you just want the cables done, then you could buy those pre-assembled cables, and they're very nicely made and they work great, of course. But if you're going to buy 3 or 4 pre-assembled cables, you might be able to buy the cable, the connectors, and the crimping tool, and maybe it's a push. I haven't done the math to figure out where the crossover point is, but I bet if you make half a dozen cables, you're going to ultimately save money by making them yourself.
Yeah, that is true. I mean, for convenience sake, when I live close to ham radio outlet, I'd buy the PowerWorks ones every now and again, and then actually even bought a complete set of pretty much every power pole type adapter or jumper cable they had just to have as utility cables in a toolbox. But as an example, the DC load that I have is it's capable, I think, of drawing up to 60 amps, which is a lot of energy, and it's got very large lug posts on the front of it. And when I was originally running my tests, I was using the PowerWorks 12 gauge leads, and the battery would have one on it, and then I'd have one connected to the terminals on that. So I had a 2-foot run, but I discovered that even at a 2-foot run, when I was doing a 10 amp test, that was too much of a drop. So I'm running the test down to 11.8 volts, and the first time I ran the Bioenno Power battery, I only got like 6.7 amp hours, which seemed really low. So I went over to the electrical my supplies, pulled out about a foot of 10 gauge wire and put fast on, which are the F2 type terminals that are common on these batteries on one side with my crimper tool, and crimped on some big heavy duty 10 gauge lugs on the other side and put those on. And now the voltage drop at high currents is virtually insignificant in my testing because it's a really short run and a really heavy gauge cable.
And that's a really good point because it's very easy to scrimp on things like that. So it's easy to say, well, I've got this wire that looks big enough and it's 20 feet long and what the heck, just hook it up and things will work, but it won't be efficient. You'll be losing power because of the resistance in the cable. You won't be getting the voltage at the radio. You won't be getting the RF output power level you want. So I think that's some very good advice to go with the largest cable you can get away with. Now, you don't have to go to jumper cables exactly, but something reasonably good size gauge like the 12 gauge you mentioned. I use 14 a lot, for things, but much below that, then you're going to lose power in the cable.
Actually, we'll just go ahead and say definitely don't. 14 in a pinch, 12, but 10 ideally for main power runs. Now, another thing we kind of didn't cover, but the majority of these ham supplies generally provide between 20 and 30 amps of current, and some of them may even say, 20 amps nominal, and it can do peak at 25 or peak at 30. But one of the questions I've always had with these supplies, especially the less expensive ones, is it possible that if you are really running a supply hard, then, the more load, the more current you're drawing out of it, does the quality of the power coming out of the supply become somehow unstable or dirty?
No, generally not. I've rarely ever seen anything like that, but the voltage will sag, or it just won't put out the current. So you really want to over-spec the power supply for the maximum load at the station. So the two specs you mentioned are very important to understand: the continuous level of current and the peak. So the way that they spec these things out, they say, well, if you're going to put a load on the power supply constantly at a certain level, then buy the power supply whose maximum constant current is what your load requires. I would put even more headroom on that. So let's be more precise with an example. Let's say you've got a 100-watt HF radio, and most 100-watt HF radios will draw 20 amps key down in transmit with 100 watts out. So you would think, well, how big a power supply do I need? A 20 amp supply. So the minimum spec power supply you'd want is a 20 amp continuous power supply, which is typically, like you said, Jeremy, 25 or 27 amps peak. However, that's when you're speccing the power supply exactly at the maximum load. And I would give it more headroom. So for me, a very typical power supply for a 100-watt transmitter would be something like the old Astron RS-35. The RS-35, 35 meaning 35 amps peak current, with a continuous amp rating of about 25 amps, and you know that your transmitter is going to pull a maximum of 20 amps, that's a pretty good fit. And that gives you enough headroom that you're quite confident you're not going to stress the power supply. Now, of course, if you have other accessories in the station, in addition to the radio, maybe you have a VHF radio, or maybe you have some other accessories, all that current consumption does add up. So you got to look at the total load.
And it does. And in my particular case, the power supplies I have are around 25 amps. And I know that if I were to do, key down at 100 watts on an HF radio, it's going to be between 20 and 23 amps. And then using like a normal 50 watt VHF UHF radio, you're looking at between like 12 and 16 amps on one of those. So there's a little bit of responsibility for you to realize you probably shouldn't be talking on both of them at the same time.
Yeah, and realistically, you're probably not. But if your mobile radio draws an amp in receive, that's still an amp. So that's always on for sure. So, you really do have to look at all those elements that add up to the total load of the station. What you really want to do is you want to match the power supply to give you enough headroom, I would say about 20% or more additional capacity over the maximum capacity that you need based on the load.
And of course, in this particular instance, a lot of you are already going to have these power supplies, and a lot of you are not going to go out and buy second or third power supplies just to keep on the bench. You're going to grab the one that's with your HF station, or you might do your testing at your HF station. But, do just remember that at the end of the day, probably don't have a power supply that can do everything all at the same time. But then again, on your bench, you may also not need that.
Yeah, so these big power supplies for bench purposes are really there to work on radios. That's really not going to be used to power small, delicate electronics. So let's talk about the other kind of power supply you mentioned.
We have to make our recommendations.
Oh, okay.
Yeah.
Go for it. What would you recommend?
Well, I think that on the linear front, there really is only one option, and it is about as ubiquitous of a power supply as can be. But as you mentioned, it's an Astron RS-35 Alpha, which is capable of 25 amps continuous, 35 amps peak, available for about $180. And of course, we'll have links to all of these in the show notes.
That is like the cockroach of power supplies. Those things. The reason those are great power supplies is what I mentioned earlier, that the components that are used in those supplies have been around for decades. It's super reliable. It's repairable. You could fix it with big fingers. It's not a very delicate little thing inside. It's just a solid basic power supply.
It'll hold big doors open.
What would you pick if you were getting a switcher?
So on the switching front, the good news is at this point in time, technology has given us hams a lot of good options. I would say what is probably the most ubiquitous power supply in amateur radio is probably the Samlex 1235 series, which is available both with meters and without. In the metered version, have analog meters. It is available for the metered version is about $130. The unmetered version, I think, is $110. But this is if I can remember correctly, 20 amp continuous, 25 amp, peak. And actually, its peak time is like peak for up to 2 or 5 minutes. It's a pretty good rating. But this is certainly one of the cheaper supplies on our list. And again, these things are rock solid. My first power supply was a Samlex. In fact, I had it on 24/7 doing different things. I've never had a problem with it, and they're readily available and still manufactured. But it's a good power supply. You familiar with the Samlex?
Oh yeah. I've got I have the non-metered version on a bench.
In addition to that, the other power supply that George kind of referenced earlier, Elenco has been very popular in selling a variable voltage 12 volt power supply with meters. The Elenco DM330 MVT, available for approximately $160. Actually, this one's kind of interesting because not only does it have your big lugs on the back of it for connecting to your radios, it also has some little terminals on the front for low current 12 volt applications that kind of look like speaker terminals, where you push the little piece of plastic in and there's a spring that you hole that you put the wire in. And then it also has a 12 volt cigarette lighter socket on it. So it's actually an interesting and useful piece of equipment just because it has these different interfaces. And there's even a more modern version that has, I think, 1 or 2 USB ports on it. But this is the one that has the knob that actually allows you to adjust the switching frequency, so that because it's
the power supply with a VFO knob.
But it works.
I used one of those power supplies for several years on the main HF station, and it was fine. I never had a problem with it.
Again, a good option because it gives you a lot of different ways to connect to it and use it. And then I think more recently, and I own one of each of these, I think you do too, but PowerWorks started badging a couple of power supplies. They have one that is the SPS 300DV, which this power supply I think is also, I should probably look this up. I think it's 20 amps with 25 amp surge.
Yeah, no. 24 max.
24 continuous, 27 surge.
Oh, is it?
Yes. But this is this power supply is really cool because it's tiny. And another thing that's cool about this is that there is an option to get these little brackets so you can mount it. If you have a Go box or whatnot, there are these little brackets you can get for it that screw into the side and then give you, holes to mount it to a base plate of some kind.
That's a really good point. I did that on a project, and it was perfect. That's the best power supply for that application because of that.
And it has a pair, or I should say 2 sets of power pole connections on the front of it, and then the back has your regular 5-way binding post.
The one that I have is different than the one you're describing. I'm using the PowerWorks SPS 30DM. That's the one with the digital display. Mm-hmm. So that thing has the connections on the back, nothing on the front.
Yes, it's a different, like you said, that's the DM model, which is about $160. Same specs?
Close. 22 continuous, 24 surge.
Now, this power supply is notable because, again, it has a digital voltage and current meter on the front of it that updates about a little tiny bit faster than once per second. This power supply also is variable voltage, and it can go between 5 and 16 volts DC. It's actually mine will do up to 16.7 volts. And then there's a switch where you can put it on a fixed version so that even if you turn the knob, it won't, it won't lose its adjustment.
And I think the fixed voltage is even adjustable, but that's with a little pot on the inside.
There are 3 pots on the inside of this power supply, and I've adjusted mine before, but I don't remember which one is which. One of them adjusts, it's an offset for the voltage meter. So you stick a digital multimeter in the back, and get a reading from a trusted meter, and then you can adjust it so the two match. One adjusts what that fixed voltage is, and then I cannot remember what the third one does. And of course, in order to do this, you are voiding the warranty. There's a sticker on these power supplies that says void.
So I mentioned I use this as my Shack power supply driving the power gate. The reason I got the digital one, not only because I needed to set the voltage, but I do actually look at the current on the display. And the reason for that is since it's hooked up to a battery system and I'm charging the battery when it's low, I want to see what the charge current is. So I want to be able to look at where the juice is going. So if all the loads are shut off and I see there's current being drawn, I know I'm charging the battery. So that display is very handy.
So what's funny is that I purchased this power supply for a similar purpose. I use this power supply to simulate the sun. I know that sounds ridiculous, but for the charge controllers that I've had over the years, the solar charge controllers I've had in testing them, especially in some of my earlier lithium batteries, I wasn't smart enough to know how you charged these lithium batteries, but I knew I had charge controllers that could do it. And the charge controllers really wouldn't kick in unless they were getting voltage over like 14.6. So I get this thing, I crank it up to 15, 16 volts. The charge controller activates, and I will actually watch there and see the current change as the maximum power point tracking kicks in, and then I can basically use it to charge some of my lithium batteries.
Nice. Well, actually, if you use that with your programmable load, you've got a pretty sweet setup. So one last thing on these big supplies that you might be thinking too is I rarely have my power supply on the in the shack in a place that eats up valuable counter space. So I want all my radio gear in front of me, but the power supply is a thing. It's a brick. You don't need to interact with it. There's no point in having the power supply take up space next to your radio. So personally, I put my power supply like 3-4 feet away from the radio under the table or next to it some, far away. There's no reason it has to be not far away, but a few feet away. It doesn't have to be sitting next to it on the desk.
I keep mine on the workbench, but again, I have ones with meters, and they have knobs for adjusting voltage.
Yeah.
So it's it's not just furniture. That's how I'm able to control it. And because they're on the bench, that allows me to keep the cable run short, as we referenced earlier. One of the things that we talked about, but we didn't really deep dive on, but it is kind of the accessories around this. Like I said, I have a rig runner, and for those who aren't familiar with a rig runner, basically it is a bent sheet metal box that's very nice. It has a nice screen printing on it. Inside there is a circuit board with very large traces, and these things are available in total of 40 amp capacity and 80 amp capacity. And basically, on the small side, there are 5 sets of power poles, and 2 of them will be rated at 25 amps. And then you might have a couple rated at 10, one rated at 5, and then one rated at 1. Some of these things have USB ports built into them, and there's actually a model that's more recent that actually has a voltage and current meter built into it, plus low voltage disconnect. But anyway, when I talk about having a 12-volt rail, having that thing allows me to connect multiple 12-volt devices to one single power supply without having to have a bunch of separate leads. And I think, it's a very handy piece of equipment to have. But of course, they are expensive, and there are alternatives out there. PowerWorks even sells some different options for connecting multiple power poles together. They don't really have a lot of features. It's literally like a little ball with 4 sets of power poles on it. But if you need to be able to share one power supply connection with multiple devices, it certainly gets the job done.
Well, I get a beef with something that's kind of like that. There's a company that makes something that is very similar to what you're describing, but instead of power poles, they use binding posts. Binding posts are really kind of lousy for this purpose. And the reason is, number one, when you twist the binding post, if you twist a little bit too hard, it could spin on you. So now you might have a loose connector that you have to then take the thing apart to tighten it back up. The second thing is, if you are using lugs, that's okay. But if you use the banana connector as a 12-volt DC connector, it's not a good idea, mainly because if any of that banana connector is exposed, it's a short circuit potential. So I just think those are terrible. So if you have a power supply where on the back of it, all it's got is binding posts, well, okay, fine. But if you're going to have a whole, essentially like an outlet strip for 12 volts, I would use the power pole ones, not the binding post ones.
Well, and to that point, I mean, the power poles are a fairly can be a contentious topic. And for those of you who aren't familiar with Anderson power poles, it is a standard power connector made by Anderson that basically there is a metal blade that gets crimped onto your wire. They come in different sizes, and the size also relates to the current carrying capacity. So the three most common that the amateur is going to run into are going to be 15 amp, 30 amp, and 45 amp. And honestly, talking about the 15 amp is pointless because you should not be using wire that small. The 30 amp ones have a, kind of a tube on the back end that you slide the wires in. And then the 45 amps kind of have a U-shaped channel that you set the wire in. You use the crimp tool that we referred to last time. The PowerWorks version is called the Tri-Crimp, which has holes for the 15, 30, and 45 amp versions. It gets crimped on there. Some people, like George, like to solder them after they've crimped them. And then there is a plastic housing that slides over it and locks into place. And the blade that you have crimped onto the wire makes a very strong mechanical connection to this thing inside to keep it locked in place. The plastic housings come in many different colors, but of course the most common are black and red. And then the two housing pieces actually slide together physically, so you have created a keyed plug that is basically protected from short circuits during connection because the entire electrical connection is shrouded in plastic. And you can actually even assemble them to make complex plugs. Like if for some reason you needed to be able to plug in two pairs as one single plug, you can do that because these things kind of slide together like Legos.
Yeah, they're really awesome connectors. One thing that's a big plus with them also is they're symmetrical, which means that when you put a pair of connectors on each side of a cable, the two sides are identical. So there's no notion of a male-female connector. They work fine whichever end of the cable you're on. So it just makes it really handy to make extension cables or just about anything else. So that's the way to go.
And each individual plug has an orientation. Like there is a top, bottom, left, and right.
Yeah, you won't plug the hot into the ground side. You really won't cross connect them and short something out.
No, but the point that I was getting at is this was kind of like an unexpected benefit from them. So generally speaking, they're put side by side, and I do not remember the mnemonic to remember which side red goes on versus black. But I can grab any other cable I have in here and look at it. But when I built my first kind of solar generator box, I wanted to make absolutely sure that nobody plugged and tried to plug an accessory into or a power supply into where the solar panels went in, just to make sure that, definitely keeping that separate. So I used gray and green shrouds, the plastic shrouds, and then I was able to assemble them on top of one another instead of side by side. So that kind of keyed them so that I couldn't accidentally plug any other accessory 12-volt thing that I had into that port. And also to that point, all of my 12-volt stuff has been standardized on power poles. Like even the battery tender battery chargers I have, which are very popular, ubiquitous AGM battery chargers. I cut the terminals off that they come from the factory, and I terminate them with power poles.
Yep, I do the same thing. Everything I get fresh out of the box, I cut off the proprietary connector and put on power poles. Everything is power.
The world.
All right. I think that kind of does it for the shopping list of power supplies, the big 12-volt power supplies, right?
Yes, and we've covered the uses. And again, everybody's familiar with this. I guess actually the last thing that I will say is that, we often get asked, well, what happens when I spend more money? For these types of high current power supplies, if you buy one of the ones we recommend, there's no reason to spend any more money. No. Unless you have a need where you really want a 60 amp power supply, like that would be about it for these large utilitarian brute force power supplies. Like you don't have to spend a ton of money on these. The recommendations we made are pretty much the recommendations.
Yeah, I think it'd be solid with any of those, and they'll last you a very long time.
Now, let's get into the lab grade power supply, which that sounds really fancy.
Yeah, lab grade makes it sound unnecessarily expensive and finicky. So let's just call it a bench supply, a variable voltage bench supply. How about that?
What about a precision supply?
All right, let's go with that.
Okay, well, a variable voltage bench precision supply.
Describe in layman's terms, what is that thing?
This is going to be a power supply that I am using for low power applications where I need a lot more precision and being able to adjust voltages. So for instance, if you're working with an Arduino that wants to be powered and have all of its accessories powered with 3.3 volts, you're not going to plug it into your Astron. You're not going to plug it into the variable voltage Alinco. Because you very much need to be able to make sure you're turning it to 3.3 volts and it is actually being set at 3.3 volts. These power supplies also have some different features on them. Their purpose in life is not just to dump as much power into things connected to them as possible.
That's right. So the first thing that you look at when you're looking for a power supply like this would be what's the voltage range that you might expect. And I guess it depends on what you're going to build. And of course, you don't know what that is going to be 2 years from now. So you want to get a power supply that's got a reasonable set of specs that'll handle just about any project that you might do in the future. So what would you pick as some of those top level specs?
Well, first of all is the voltage range. And I think what is probably good for 90% of the usage that our listeners are going to run into is a supply that can give you between 0 and 20 volts with the ability to adjust the voltage down to the tenths or even the hundreds. So that it's not just 1, 2, 3, 4, 5. You can actually do 1.8. You could do 5.25. You could do 3.3.
Yeah, and there's certain voltages that are common for different projects. So in small electronics, integrated circuits and such, 3.3 volts is very common. 5 volts is common. In some audio circuits, perhaps plus and minus voltages. If you're going to do, let's say, radios, they could be anywhere from 8 volts to 14 volts, even low current kind of radios. Handy talkies, for example, you might go as low as 5 or 6 volts, as much as 13 volts. If you're working on stuff with relays come in different coil voltages: 5 volts, 9 volts, 12 volts, 15 volts, 18, 24, 28. So depending on what you're going to be working on would determine what that highest voltage is. But I'd say for most things, like you said, 20 volts would be a good max. You often find these power supplies going up to maybe 30 volts, but that's about the top that you tend to find.
Yes. And we're talking about these, generally speaking, for, again, 99% of the things you're going to be working on, you're only going to need a power supply with a single output. Now, these benchtop variable voltage precision power supplies are available in 2 sets of outputs or 3 sets of outputs. And as an example, you may have one that's capable of doing 0 to 30 volts on 2 of the outputs, but then only, say, 0 to 5 on 1 of the outputs, because that particular output is incredibly high precision designed for digital circuits. George, you kind of referenced about the positive and negative voltage. Is that something that our listeners really need to worry about?
It depends on what you're designing. If you're going to work on, I would say 90% of the electronics out there, you just need a DC supply voltage rail. So your circuit's going to run on 3.5 volts or 5 volts or 6 volts or 9 volts. So you just need a single power supply output voltage. And what Jeremy's talking about is power supplies that might have a plus and minus voltage. And these are called dual-ended power supplies typically. Now, why would I need such a thing? So not only does it put out a positive voltage, it puts out a negative voltage. The main application that we might run into on a ham bench project would be an audio circuit. In a lot of audio circuits, the op amps, the operational amplifiers, the chips that are used to either amplify or filter an analog audio circuit, those chips traditionally are powered with a plus and a minus voltage rail. So if you imagine like your voice or a sine wave, it has a positive voltage swing and a negative voltage swing. So those chips have to have a positive and a negative voltage. Now there's other techniques you could use to run op amps off of a single-ended supply, and someday we'll talk about that. But that's probably the most common application. So unless you're really doing audio circuits where you need a dual-ended plus and minus power supply, I wouldn't worry about that. You really just need a standard variable voltage single power supply output.
Now, the next spec, of course, when we talk about power supplies, they have a voltage and they have a current. And one of the things that is notable about these supplies is you're going to find they are much lower current than the big brute force power supplies we talked about for running a radio. Generally, the ones we're going to be talking about will only be capable of anywhere from 2 to 5 amps of current total.
And that's because typically these power supplies are used to power let's say, a circuit board with some integrated circuits or transistors. They're relatively low current circuits, and you don't need a huge power supply to run these little components.
No, what's interesting about this is, some of the power supplies we're going to recommend are only capable of 3 amps, which is good for probably 95% of your applications. But what's interesting, as the world of USB power marches on, circuits where you may be powering something via USB using one of these supplies, but then also using the 5 volts for some other application, you may actually need more than 3 amps. So 2 to 5 is safely a good range.
So think about it this way. If the project you're working on has a collection of integrated circuits and or transistors, then this is plenty of current. And it's only when you have either a special power application or a transmitter, which is putting out a significant amount of power, where this won't be sufficient. But for most applications, so let's say you're building an Arduino-based remote relay for your antenna system. Well, that whole thing is probably going to draw no more than a couple hundred milliamps. So this is more than adequate. Or let's say you're working on a handy-talkie and you don't want to run it off the battery. Like a lot of times, if I've got a HT that I'm working on, I'll crack the case open, but rather than to power it off of the battery, I'll remove the battery and I'll hook it up to a variable voltage power supply. That way I could adjust the voltage and I could also see what the current is that's being drawn. That's a much better way to work on the equipment. And we'll talk about some of the safety reasons for that in a minute.
Another feature of these is these variable voltage supplies are all going to have meters. They're going to have a meter for voltage and current, or some of them may have only a single meter that you can switch between voltage and current. It's very difficult to find ones with analog meters anymore. Pretty much all of these are going to be digital. And you're going to have a varying degree of precision. Some of them may be able to show down to the hundredths decimal point, which is probably the most common. Higher end supplies will be able to get you down to the thousandths as far as a degree of accuracy. But for anything that we're going to be doing, being able to show down to the hundredths or two places to the right of the decimal point is going to be more than adequate for our needs.
So let's talk about one of the most important features that you're going to want to have on a power supply like this. So since you're building electronics on the bench and the stuff you're building may or may not be working properly, one of the biggest concerns that you should have is what happens if there's a short circuit in the project. Imagine you have your 25 amp 12 volt power supply, and even if your circuit runs off of 12 volts, if you didn't design the thing right or build it right and there's a short circuit, if you plug that little board into your 25 amp supply, the supply will be more than happy to supply 25 amps to that little circuit board,
thereby releasing all of the magic smoke.
So what you've got then is a big expensive fuse, which, by the way, on an earlier episode, we said whenever you need a part by 3, this is one reason. But there's a magic circuit that is in these benchtop precision labby kind of power supplies. And the first feature that you want to look for is a current limiting power supply. That means exactly what it says. It means that you can set the maximum amount of current that power supply will deliver to the load. So if I have an integrated circuit and some discrete components, and I think that whole circuit should draw no more than 100 milliamps, I'm going to set my power supply's maximum current to maybe 300 milliamps. So it gives me a little bit of headroom. But if it goes over 300 milliamps, then it's going to shut off. It's going to immediately stop supplying power to the circuit because there's obviously something's wrong. And I want the power supply to stop working to basically turn off the juice and not fry the electronics. So that's a very important feature.
I have a good practical example of this, which is fairly straightforward. So I have a power supply like this that's capable of doing 1 to 36 volts, which I'll recommend here in a moment, up to 3 amps. And I had recently purchased some USB female plugs because I wanted to be able to use this benchtop precision variable power supply to power some USB devices. The problem is that looking at the spec for USB to understand which pins were the power pins versus actually soldering them onto this little plug had me nervous, and so I wanted to be able to plug something into it to test. I just so happened to have a 5 volt USB fan nearby, and I was able to set my power supply to only let 50 milliamps go through, and then I could turn that up slowly to make sure that I had in fact soldered things correctly and that the polarity was correct for the fan, thereby preventing me from plugging, say, a Raspberry Pi into it and watching the smoke flow out.
Yeah. So those power supplies, not only do they limit the current and shut off, but they also have a feature typically called short circuit protection, which means that if the output of the power supply, the hot and the ground touch, there's a dead short across it, it'll also shut the voltage off to the output. Now, some of these power supplies will automatically reset. In other words, when the current consumption goes below the threshold you set or the short circuit goes away, they automatically turn back on. Other power supplies have a reset button where you have to manually press a button to tell the power supply to start working again. Either way is fine. So that's just really a very important feature to have. And virtually all of these power supplies would have that as a standard feature, but you want to make sure you look for it.
Yes. And generally speaking, the interface for these, you will find they will either have 2 or 3 binding posts.
My favorite connector.
Well, I mean, what's interesting is depending on the supply, you may not have binding posts. You may just have banana plugs. For instance, the Tenma supply that I have on my bench, the small one I just referenced, it just has banana plugs. What's interesting, though, is that it has 3 connectors.
Because?
Well, there is the positive, obviously, and then there is ground, which is reference ground to the circuit inside the power supply, and then the third connector is common ground, which is earth ground, reference to the what's connected out the back of it if you have it grounded, or to the ground pin on the power cable.
Do you know why they do that?
Dave Jones has a great video about how you can screw things up if you're connected to the wrong one.
Yeah. There's kind of many reasons, but the main thing is the power supply voltage may not be referenced to chassis ground in the target circuit. So that green connector usually, which is the earth ground that's like the box of the power supply, the case of the supply is that earth ground. The black or negative side of the power supply may not be hooked to that, and often is not in a lab supply, because you want to have that voltage potential between the black and the red lead not referenced to an external ground. Because the circuit you're actually going to be powering with that may not be referenced to the ground of the power supply. So you want that voltage differential just between those two connections, the red and the black. You don't want it referenced to earth ground. Which
a good example of that would be what?
So let's say, for example, like if you had a set of batteries in series. If I have 2 batteries in series, let's say 2 D cells in series, they're 1.5 volts each. Put them in series, that's 3 volts. If I measure between the edges of the 2 batteries, I see 3 volts. If I measure between the ends of only one battery, I see 1.5 volts. That voltage measurement is only between those 2 poles, not referenced to earth ground. If I were going to replace the battery with the power supply, I want that 1.5 or that 3 volt potential, but not referenced to ground. So it's kind of a lame example, but you don't necessarily, if that power supply was trying to emulate one of those battery cells, then the ground side is not earth ground, because it might be the bottom cell in my series, if you follow my lame analogy.
Well, I'm going to keep pulling on this thread to make sure that our listeners and myself understand. The jeopardy of referencing a circuit to earth ground when you don't want to is what? Is there the potential? As I understand, there's a potential for current to flow.
Well, there is, but even that, I mean, that's a second order thing. Let's just talk about, let me give you an example. I'm going to make up an example. Take our little battery example. I've got a circuit, it runs on 3 volts. And I have 2 batteries in series to provide the 3 volts. Now, if I were going to put a power supply on that circuit to emulate the battery, I'd set it for 3 volts and it would just work. Let's say I want to emulate those 2 batteries. I could take 2 power supplies and I could wire the power supplies in series so that the negative of the first power supply is the negative of my circuit. The positive of my first power supply hooks to the negative of my second power supply, and the positive of my second power supply is the positive of my circuit. So I've replaced the 2 batteries in series with 2 power supplies in series, and I set them for 1.5 volts each. Now, if the 2 grounds on the 2 power supplies were both referenced to earth, they would be connected together. Well, that's not what I want. I want that 1.5 volt potential coming out of the two power supplies to be completely independent of an earth reference.
So it's not just that they're connected together, it's that there's an opportunity for them to short circuit through earth ground at that point?
Well, yeah. I mean, think about the negative, the positive and the negative coming out of the power supply are independent of the earth. It's a potential between those 2 points. If I have two power supplies and I could hook the power supplies in series, I now have the total potential is the two power supplies added together. So if I have the two supplies, each set for 1.5 volts, and I put the power supplies in series, I now have 3 volts at the very edges.
Mm-hmm.
Okay. If the ground, if the black side of the power supply was tied to the earth chassis of each power supply, then the second power supply in series, the ground side, would be connected to the hot side of the first power supply, which would short it out.
Because they have a common ground, which is that earth ground.
Correct.
Yes.
Correct.
Okay. So I will take a note because, like I said, Dave Jones has a really good video that kind of explains the danger of earth grounds. He tells in the context of having an oscilloscope that is referenced to earth ground and then working on a circuit and then end up having, basically creating a short circuit situation like you just mentioned. It's one of those things that it takes a little while for it to be intuitive, but it's important to know this. But the long and the short of it is that for the types of things we're going to be working on and the average ham is going to be working on, you will not need that earth ground. So do not seek that out as a feature.
Yeah, not really necessary. In fact, almost every circuit we'll do is a single-ended ground referenced circuit. So this is all rather esoteric debate here, but that's the reason why that ground is typically isolated from the earth.
You say it's an esoteric debate, but I can tell you, for the person who's excited to just see the shiny new power supply, and of course we love new tools, and they see this and they have not considered, well, I have a black plug, a green plug, and a red plug. Mm-hmm. We have just armed them with information to not just immediately plug stuff into the green plug unless you have a damn good reason to.
No, that's a really good point. So the simple kind of common sense here is when you're applying that DC voltage to the target circuit, you use the black and the red and ignore the green. It's kind of the shorthand version of the last.
That's the short, and hopefully we've covered why. Okay, so we've beaten that one to death.
Yeah.
But, again, an important thing to learn. Overall, as you spend more money on a power supply, you are going to find that it becomes more precise, like a lot of these instruments. What other benefits are there by putting money into a power supply?
Well, I think if you get a good one, it'll last you for a long time. The big thing is that the price of these things have come down dramatically, like all electronics have. So you could buy a very good quality variable voltage test supply like we're talking about for really pretty reasonable price these days, probably half of what it was 10, 15 years ago.
So another thing, we were talking about switching versus linear supplies with the big power supplies. Is that still applicable to these precision supplies?
Well, that's a good point. Most of the fancy supplies are switchers. Now, it's also true that switching supplies for small electronic circuits can also pose a problem. Just like they pose a problem for radio interference with big supplies, they could pose an interference problem with your little circuit. So a switching supply might put ripple or other noise on the output of the power supply. So depending on your application, that may or may not make a difference. So if you're doing an audio application and you're powering this audio circuit with a switching supply, if it's a very good switching supply, no problem. If it's not, you could be inducing noise on the supply, and you can actually hear that in the audio circuit. So you do have to make sure that, depending on the application, that you do get an appropriate quality power supply.
So you mentioned ripple and noise. What are those?
So ripple means that the voltage, in theory, the voltage output of the power supply is constant. You set 3.3 volts and it, by God, is a flat line 3.3 volts. The truth is that voltage will oscillate very slightly, go up and down and up and down, if the power supply doesn't have very good regulation or good filtering or has a noisy regulation circuit. You'll see a very slight variation in that voltage, and that's the ripple, or it could be viewed as noise. The noise could be induced from the switching circuit in the switching power supply. So some of these supplies are linear, and some of these are switchers, just like the big high current supplies.
Now, one thing I will say is that I have seen linear power supplies in this range, but they tend to be freakishly expensive.
Well, or you can build your own for $5. So you can go to your favorite parts house and get an LM317, which is a 3-pin voltage regulator, and that thing is super simple to hook up. So the question about whether or not your switching supply for the lab bench power supply is a big deal really depends on what you're designing. If you're designing a circuit that's got a very small amount of voltage and any little noise will cause a significant change in the way that circuit works, then you have to be concerned about it. If you're building very simple circuits, let's say, for example, I'm powering an LED, ripple or noise on the power supply will make absolutely no difference whatsoever because the LED, the difference in the intensity of the LED is so minuscule with a slight voltage fluctuation, it makes no difference at all. So it very much depends on your applications as to how fancy or high quality of a device you really need.
Well, and in a lot of instances also, if you're working with modules, and of course we always go back to Arduinos and PICs and all this stuff, but if you're working with boards that have some type of a power supply connector on them, chances are there's a regulator that will actually clean that power up before it gets into the circuits on whatever that module or board are as well.
Well, that's an excellent point. So that's often the case in which the power supply could be a fairly inexpensive supply.
And a good example of this is the Raspberry Pi. There are 2 pins in the GPIO header that you can just put 5 volts into, but it's an unregulated voltage connection. So you have to make sure the power is fairly clean, whereas power that comes through the USB port does go through a voltage regulator to make sure it is nice and clean before it goes off to the other components in the board.
Yeah, that's a great example. That's exactly right. So if you were going to go buy a power supply like what we're talking about, which ones would you look at?
I spent a lot of time working on this when I was trying to build out my bench. Personally, I have a supply that's available through MCM Electronics that is made by their house brand, Tenma. The supply I have is the 728435A, which I'll put a link into because that's kind of a mouthful. This supply, as I mentioned, is 1 to 36 volts, up to 3 amps. I like the display because it's an inverted LCD, so it's white text on a black background. There's a button on it that you can press to activate and deactivate the circuit, and it's available for about $150. If for some reason you needed a 5 amp version of it, they make it same power supply, but it's 1 to 20 volts, 5 amps for $160. There is also this is another supply this is kind of a luxury in my book, but Tenma also makes a model that is the 729465. It's also a 1 to 36 volt 5 amp power supply, but this one is actually USB controllable and also has a serial port and some manual pins that you can remotely control it. And this may be useful if for no other reason than if you don't have room to keep your power supply in your bench, but you still need to be able to see what the meters are telling you or make adjustments, but you do have a little computer on your desktop. You are able to control it through the computer, which is kind of cool.
That is pretty neat. I've never tried doing anything like that with the power supply, but that sounds like it'd be useful. It might be useful if you can remotely control the output voltage. If you want to do a test where maybe you're sweeping a voltage and you could do that under software control, I think that'd be very useful.
And there's also the opportunity to remotely control, I think, if the supply is actually, if it's actually outputting voltage or not. Another one that I would recommend as far as, and these are kind of on the lower end, like they're not the bottom of the barrel, but these are good starter supplies. Like, they do have a little bit of ripple on them and whatnot, but generally negligible for anything that we're going to be working on. Another one is by another company called GW Instec. And it is the GPS 1850D. This one's available for about $200, and similarly, it's a 1 to 18 volt power supply that'll do up to 5 amps. But for the money, for $200, it is an incredibly clean signal for a switching power supply. And GW Instec is one of the better Chinese manufacturers that hobbyists have access to. And then I will add that generally speaking, all the same rules about having high quality power cable still matters. I mean, the 10 gauge is ridiculous at this point because you're only talking about 3 to 5 amps. But investing in some good quality test leads or building your own that have a banana jack on one side and then terminate maybe to power poles, terminate to a USB connector, terminate to 0.1 inch connector or pins that would go into like a breadboard. There's just several cables you're going to want to purchase or make for interfacing that power supply with various things.
I find 90% of the time what I use with my variable supply is a set of test leads with a banana plug on one end that plugs into the power supply. And at the other end is an easy hook, the little plunger grabby hook thing.
Oh, yeah. It kind of like you manipulate it similar to a syringe where you hold it between your fingers and push on with your thumb and the little tiny hook comes out the other end.
Yeah, exactly. And I have one on ground and one on the hot side, and I find that is super useful because you can clip onto wires, you can clip onto headers, to just about anything. So I use that mostly.
That's a really good tip.
I'm going to tell you about my variable voltage supplies. You're going to laugh me.
Were they the ones that were they the ones that came over on the Ark?
No, it was the Santa Maria or Nina the Pinta.
The Nina the Pinta and the Santa Maria.
So I have two B&K Dynascan 1601s, and these things are like vintage 25-year-old power supplies. These are old linear variable voltage supplies, 0 to 30 volts, 0 to 2 amps. They have the current limiting. They have the reset button. I love these things because if for no other reason, if I put a piece of delicate electronics on them, and if for any reason it goes over the current threshold, the things drop the voltage to 0 immediately. It's super fast. And, okay, they're old, but they work. So, I mean, this is sort of an example of, you buy yourself a good power supply and you can keep it for 20 years. I mean, it's probably not going to go bad. It could, but most likely these things will last you for a long time.
Now, I'm assuming these things have analog meters on them?
They do, actually.
Okay. Well, I was going to say, I'm also assuming, actually for that vintage, because switching hadn't really necessarily been figured out, are they linear?
Oh, yeah, I think they're linear.
And then, so that means they weigh 4,000 pounds and are probably the size of a Buick.
Well, they're only 2 amps max, so they're
a small Buick.
They're about a foot wide, about 3 inches tall, and about 8 or 9 inches deep. They're probably twice the size they need to be.
I was going to say, like the little 0 to 36 3 amp supply that I have is about maybe 2.5 inches wide, 5 inches tall, and maybe 6 to 8 inches deep. So I could fit like 40 of them in the space to put this. But in all fairness, I bet you can find those used for really good prices.
The funny thing is you can find them on eBay, old and kind of beat up, and the prices are between about $50 and $90. At that point, you might as well just buy a new one with a digital display, like the ones you were talking about before. There's really no reason to get these off of eBay, although I really like them. I think they're great. But I think if I were starting the lab from scratch, I probably would have gotten something else. But I do love the fact that when the things pop, the power goes to 0 and you have to hit the button to reset it. I like that.
So I think as our last point on this, if you were going to go ridiculous and spend like $500,
I would shoot myself in the head.
Okay. Good. We won't even mention it then.
I'd buy myself a new handy talkie. There's no reason to do that. In my mind, I mean, the only limitation is the specs. So if you get enough voltage and enough current with high enough quality regulation, you're fine. And I don't really think you need to spend more than, $150 to get something really good.
Cool. Is there anything else we can say? I every time we do this, I surprise myself. Spend half an hour on screwdrivers, spend an hour on power supplies.
I think that kind of summarizes it. So I guess I don't
think anybody wants to hear anymore, even if there were more to talk about.
There's nobody listening at this point. Just you and me.
Maybe we can start our song and dance routine now.
That would be embarrassing.
Yes, it would be.
So let's wrap on power supplies.
All right. That's it for power supplies.
The Workbench is also brought to you by MCM Electronics, purveyors of everything you need to outfit your workbench, from hand tools, soldering equipment and supplies, meters, power supplies, oscilloscopes. MCM Electronics has these and more tools you'll want to put on your bench. MCM Electronics also carries the parts, components, semiconductors, and modules to help you build your next project. They also carry a wide assortment of Raspberry Pi and Arduino boards and accessories, including stock from Adafruit. It doesn't end with Workbench tools and supplies. MCM Electronics also carries the things you need to help you build your next ham radio go box, such as weather-resistant plastic cases and standard and shallow-depth 19-inch rack flight cases. Find them online at www.mcmelectronics.com, and don't forget to save 5% on your next order with the code RADIO5. That's www.mcmelectronics.com.
So this week we have a bunch of really good questions from Dave, KB0DWR. And Dave's first question has to do with planning out a workshop. So Dave's in a very lucky position. We all wish we were in this same situation where he gets to design his workshop. And the first question that Dave asked is, what kind of AC circuits do I need? In other words, do I need just 120 volts or do I need 220 volt service as well?
Well, I think the answer to that question is actually, for, again, 99% of things, you should get as many 120 volt circuits as you can. But in Dave's position, where he's getting to actually build out his space from scratch, and I believe he also said he's going to be operating from there. If you can, and you're paying to have the electrical service work done, go ahead and put the 220 in, because you need an amplifier.
That's right. If you don't have one, you will want one later. So,
but for Workbench purposes, no, you don't need the 220. But having a good number of 120 volt circuits in there will be good, because you also don't want just one circuit running in there, running everything off of it.
That's right. So you want multiple drops of 120 volts and at least one circuit of 220, just in case.
You're a very wishful thinker. All right.
Okay. The next question Dave has is about ferrites, and he wants to know if he should put ferrites on his DC power cords, speaker wires, USB cables. What should he put ferrite on, and why would he want it?
So I think you and I have two different minds on this, because first of all, the question is, are you trying to protect against RF getting into these devices, or are you trying to protect against RF getting out of them?
Well, it depends on the device. So in general, should you put ferrites on various leads in the shack?
I argue that if you need to put ferrite on stuff in your shack, you have an RF grounding problem.
Yes, that's probably true.
I mean, the first place to start is to use good, and there are books written about this. The league has information, plenty of experts on the internet, in air quotes. But I think your goal is to start with quality shack grounding for RF. And then, once you've been running, you can understand, well, am I hearing some things getting into my speakers? And then I think you should address them, those issues individually. But one thing I do want to point out is the snap-on ferrite chokes that we are all very familiar with. They're really convenient, but they're not as good as a substitute for like a big ring ferrite core that you actually wrap the cord around multiple times.
Yeah, that's right. There's actually multiple things to look for. Not only is it the number of turns through the core, but the material, it makes a big difference, because some of these ferrite materials are only effective at VHF and others will work down into the HF band. So if the interference source is your HF transmitter and you have a single snap-on VHF ferrite, it will do absolutely nothing at all. If you have the right kind of ferrite, a single snap-on core will do relatively little. So I would completely support your point about multiple turns through a core. Every time that wire goes through the center is like snapping on another one of those ferrite bead things.
Yes.
So several turns. In my shack, the main station is on the second story of the house. My problem is a convenient ground wire from the shack to earth ground outside is about a quarter wave on 20 meters, which is like
That's not
the
good.
worst. No, I mean, no ground is better than that ground. So I have a real problem. And when I set the shack up, I did have a lot of RFI problems. And I wound up putting ferrites on every wire in the shack, every DC power cord, every computer cable, everything. That solved all of my immediate RF problems in the shack itself, but I was still causing RFI getting into computer speakers because they're little amplifiers that are not shielded, and it's very easy to induce RF interference on those things. So I found that I had to put ferrite cores on all of the speaker leads on all the computers in the house. And that really solved the problem. So that was a huge plus.
Well, no, it didn't solve the problem. It addressed the symptoms.
Yeah, well, fair enough. Okay. So there was still some RF around. I did put ferrites on the coax, on the DC power cords to the radios, all the computer leads and everything. So at this point, I can actually key down with 100 watts and not come out of every speaker in the house.
So I know, as you mentioned, there are VHF and UHF and HF, and I've heard people use the phrase that's a mix, some number ferrite. What mix for HF?
Well, it depends. Like most things, because it's not just HF. If you look at the characteristics of the different mixes, some of them are very effective from, let's say, 10 meters down to 20 meters, but not so much so at 40 and 80. And others are very good at 40 and 80 and okay at 10, but not great. So it really depends on the bands you want to operate. As a general rule, Type 43 or Type 31 are the most popular. They're fairly broad for most of the HF spectrum. But if you want to really hypertune your system for a particular end, the low end or the high end of the HF band, you'll pick perhaps different mixes. So when we talk about mixes, this really refers to the composition of the material that's in the core itself. So every ferrite core is made of a mix of various kinds of metals, and the percentages and the concentration determines the frequency response of that particular core. So it is really important to get the right mix. There's a fella in the UK that has a website where he puts a lot of his projects on there, and he has a table that shows the different mixes and what the frequency ranges tend to be. It's an excellent reference. We'll put that in the show notes. Another really good reference is Amadon Associates, who makes these cores, or Palomar Engineers, who also sells a lot of cores. Those are great resources. There's another manufacturer called Ferrite, and you can find some good material on their websites as well. So there's a lot of bogus information about ferrites out there. There's a lot of common wisdom which is wrong because it overly simplifies the situation, and you really need to know what problem you're trying to solve and get the right kind of material. We could talk more about that on another show.
Okay, and next on the list is, do I need an antenna tuner for 2 meters and 70 centimeters?
Nope.
I don't even know if you could get one.
No, some antennas are tunable and some are more broadband, but you don't need a tuner for that. So no, the antennas are pre-tuned for the band, or you tune them, and that's that. So there's no tuner required. And in fact, I've never even seen a tuner for those bands.
No, nor have I. Next is surge protector for antenna leads at ground bus. I don't know what that means because I don't have an antenna in my house.
So I interpret this as, do I need to concern myself with grounding anything in the antenna system, let's say at the point where the feed line comes into the house? Let's just assume that's the question. And the answer is, it depends on how much lightning and you might have in your area. Generally speaking, if you're doing a clean installation, what you really want to put in is called a polyphaser. And a polyphaser is a device that goes in your feed line, and you put it at the entry port into the house. And typically you've got a ground plate with a good earth ground, and that plate, you screw the polyphaser, which is like a little 1-inch cube metal box with 2 coax connectors. And what that thing does is, any very high voltage that comes down the coax, that thing acts like a shunt to ground, and it'll take the energy to earth. So that's a way to protect your equipment. All of our repeater sites, we have polyphasers on all of the cables entering our sites, because up on the mountaintop, there's a higher chance of having that kind of a problem.
Oh, absolutely.
So if you're in the Midwest, if you're anywhere where lightning is common, you absolutely should be using a polyphaser in your feed line, and probably some other techniques as well. But that would be the first thing I would do. This reminds me of the ARRL podcast called The Doctor Is In. And I don't know if you've had a chance to listen to any episodes of that.
I have not, but I'm aware that it exists, and I'm aware that they do a far better job of not keeping their listeners than we do.
You mean they're shorter podcasts?
I hear they're a much shorter podcast.
They are much shorter podcasts. I started listening to the show a couple of weeks ago, and I was very impressed. I think that they do a really fabulous job, and I would highly recommend it. It's two guys, Steve Ford. I think Steve is the editor for QST, and he does the show with a fellow named Joel Hallis. And Joel, I think, was the technical editor perhaps for QST in the past. Anyway, every episode they have a topic, and they talk for about 20, 30 minutes on that topic, like grounding, for instance. And Joel typically answers these questions in great detail and is really a smart guy. I would highly recommend listening to that. It's kind of like listening to a chapter of the ARRL handbook. So you won't get any product recommendations, but what you will get is some very good technical advice in a very easy to digest manner. So I recommend it highly. So give that a listen. I'm sure you'd enjoy it.
And we'll make sure to add a link to that in the show notes. Well, that is going to wrap it up for Q&A. George, what do we got coming down next time?
So next time, I think for the Workbench, we're going to start looking at measurements. We're going to look at meters. We're going to look at power meters, RF power meters, benchtop meters, digital multimeters, DC power meters, stuff to measure things in the shack and the Workbench.
All right. So that sounds great. I want to thank again our brand new sponsor, MCM Electronics. You can find them online at www.mcmelectronics.com. Remember to use code RADIO5 to save 5% off your order.
And thanks so much for listening, and we'll see you in a couple weeks. This episode is sponsored by CADsoft, makers of Eagle PCB design software. Get your free copy of Eagle at www.cadsoft.io. And by MCM Electronics. For all your electronic parts and equipment, go to www.mcmelectronics.com.
Oh, you know what they should do is they should do a Pokemon Go on the air special event. Like every time you catch a Bulbasaur or a Pikachu, you should activate.
Yeah, you got to work them all.